All right, welcome to Algebra Chapter 1, 1.1, Solving Simple Equations. First, we're going to go over what the addition property of equality is, or APE. So every time that you give an answer and you're trying to say what property we're using, you would say APE at the end for short. That way you don't have to write this out every single time. So the addition property of equality goes like this. If two things are equal to each other, so A and B are equal to each other, then if I were to add the same number to both sides, those two things would still be equal to each other. So if A equals B, then A plus C equals B plus C. And that makes sense, right? It's kind of like a seesaw or a teeter-totter. If you put weight on one end of the teeter-totter and you put the same amount of weight on the other, it's still going to stay balanced. So here's an example of when we use this property. So I'll show the whole problem here. Here's an example. So when you are subtracting something, in order to get rid of that number that you're subtracting, you're going to add it to both sides. So what we want to do is we want to get x by itself in order to solve for it. So we want to add the same number to both sides to solve for x. And that's what we did here at the top. So we're going to do that here as well. So the value that we're going to add to both sides is 7, because if we add 7, it cancels out this minus 7, leaving x by itself, and then we just solve the other side equals 1. Now I want to put APE at the end to tell, basically to say what method I used, what property. Very similar rule for subtraction property of equality, and we call this the SPE, okay? And it's the same kind of rule, but instead of plus, it's minus, right? And as we look at that, as we look at an example of this, we can see that we want to subtract the same number from both sides. And we use this property when we're adding. So notice that we're using, whatever property we're using, it's the opposite of what's happening to our variable at the beginning of the problem. So if y plus 3.4 is equal to 0.5, we're going to subtract 3.4 from both sides. So notice now I'm simplifying it. I'm not rewriting the whole equation anymore. Now I'm just going underneath and writing subtract, okay? So we want to subtract the same number from both sides to solve for y. And this should give us y equals negative 2.9. This is the SPE, so I'd put that at the end. Okay, next up we've got the multiplication property of equality, MPE, and you can probably guess what this is going to look like. If A equals B, then A times C equals B times C. Now notice something I want to point out when you are adding or multiplying, so when you're doing basically the positive version of the operation, either adding or multiplying, the order doesn't really matter. I could have this, I could be adding 7 to this side or adding 7 to this side, doesn't really matter. Same with this, I could have this be, say, C times A and C times B, or the other way around. Order does not really matter for multiplication or addition. So if we look at an example of this, we can see that if I have negative 3/4 times n is equal to negative 2, we want to multiply by the same number on both sides to solve for n. So the reason why we want to multiply here is because in order to get rid of a fraction, we have to multiply by its reciprocal. So notice that 3/4 or negative 3/4, the reciprocal of that is negative 4/3. And that's because when I go to multiply, you can see that they cross out when you look down the line. So the 4 here crosses out this 4 here, the negative 3 here crosses out the negative 3 here, right? And so that cancels out here and we get n by itself, and then we have to multiply this straight through, so we get negative 4 times negative 2. Negative times a negative makes a positive. 4 times 2 is 8, and then the 3 stays on the bottom. And I'm not picky about if you have it as an improper fraction, or if you were to actually write out, I think this would be 2 2/3. Yeah, so either answer is totally fine. I'm not picky about which one you use personally. And then you would say at the end, MPE here. Okay, let's look at the next one. Or I should say the last one. The last one is division property of equality, the DPE, okay? And it's the same type of rule. So we've got A equals B, then A divided by C equals B divided by C. Okay, so you can just divide by the same number on both sides, and it keeps the equation equal. Keeps it balanced. Okay, so I'm only going to show a little bit of this at first because you'll get really confused if I show you the whole thing to start out. This is what we start with. So if we have pi x equals 3 pi, here's something to keep in mind. Pi represents a number, right? Pi is a number, so we don't want to necessarily treat it like a variable where we're trying to solve for it. However, it does have some properties like a variable. For example, when I'm combining like terms, I can treat pi like a variable. In other words, whatever numbers are in front of pi get added and pi just stays the same. However, when I'm going to solve, I'm not trying to get pi by itself, okay? It's important to note that pi is not actually a variable, it just has some properties like a variable. The variable I'm solving for is x. I need to get x by itself. The only way to get x by itself here is to recognize what is pi doing to the x. Well, pi is multiplying. Whenever there's nothing written in between here, we can assume that it's a multiplication here, right? In fact, some of you might want to actually even write in a little dot between the two to show multiplication, okay? So what's the opposite of multiplication? Well, we're talking about this property right here. We're going to divide. So we need to divide both sides by pi. So I'm going to go ahead and do that. Divide by pi. And something that I talk about a lot is that division is the same thing as making a fraction. So if we have something on the bottom of a fraction, that's the same thing as saying divided by, right? So this right here is the same thing as if I said A over C, right? In fact, I might even write that in just to show that they're the same thing. If my pen would work. There we go. So we could say that this is the same thing right here. A over C is equal to B over C, right? Same thing, same rule, okay? So whenever I'm solving for the variable, I'm just going to use the fraction sign because I think that that's the cleanest way to write that. It's going to be the easiest way to keep it all on the bottom here. So I divide by pi. That's going to cancel out these pi's, leaving me with x. But when I divide here, the pi's don't cancel each other. Or, sorry, actually the pi's do cancel each other. I just realized I made a mistake in my answer. I'm going to have to correct that now. The pi's do cancel each other here. So I'm just left with 3, which means I actually have the wrong answer here. I was thinking of the wrong property. So you guys just caught me a mistake. So the real answer is 3, okay? The pi's cancel each other. Okay, what I want you to do is I want you to go ahead and pause this video if you need to take notes on everything right here. You can pause right here. And then when you're done pausing, go ahead and start working on these problems right here. So go to page 7 and 8 and work on these problems right here, okay? And we'll come back for a second video.